Similar polygons. When you see this symbol, an equal sign with a squiggly above it, that means what? Congruent. Okay? If you just see one squiggly, that's very technical on my terminology, I know. Squiggly. Okay? One of those means similar. I use triangles for right now. So you might see a statement that looks like this. Triangle ABC is similar to triangle DEF. So that means those two triangles are going to look the same, but basically one of them has been stretched to be bigger or shrunk to be smaller than the other one. But they're going to have kind of the same appearance. All right? It might be something like this. So they are similar figures. When figures are similar to one another, all of their angles are congruent to the corresponding angles in the other triangle. So I'll come back to this in just a second. So corresponding angles are congruent, all right? Corresponding angles are congruent. So in other words, knowing that this is true, angle A has to be congruent to angle D, right? Angle B has to be congruent to angle E, and angle C has to be congruent to angle F. Okay? Really, you don't even need the pictures to make those statements. You can tell by the order they write the letters. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. Right? So corresponding angles are always congruent to one another. Right? Anytime figures are similar, if I tell you this figure is similar to that figure, you know that all the angles in the first polygon have to match or be congruent to all the corresponding angles in the second polygon. So all the angles are congruent. Now, are the sides congruent? Are the sides the same length? No. Okay, they are not the same length, because if they were, then we wouldn't have similar figures, we'd have congruent figures, right? Right? Corresponding sides proportion with one another. Corresponding sides are in proportion with one another.
Instead of just writing for the corresponding side, instead of just writing an angle, would just the segment?
Yeah. Yep. So, AB, this segment right here, make sure everybody watches this, very close. AB corresponds with which side on the other triangle? DE. So AB and DE, those are corresponding sides. They are not congruent. But the ratio of AB over DE, whatever that ratio is, whether it's 3 to 4, 3 to 7, 2 to 9, whatever that ratio is, would be the same as the ratio of BC over EF. Okay? Which would also be the same as AC over DF. Okay? All of those ratios would equal the same number, or the same decimal, or the same fraction, or reduce to the same thing. Alright? So anytime you have similar polygons, similar figures, corresponding angles are congruent, the corresponding sides are in proportion with one another. Whatever that ratio is it is called the scale factor. Okay, whatever number those end up equaling, that is called the scale factor. Okay? We'll do one example here together. Alright, let's say these two figures are similar to one another. And they are similar, so figure ABCD is similar to HEFG. So I wrote a whole bunch of things up there. There's a whole bunch of variables still up there. There's a whole bunch of missing parts still up there, but you could solve for every single one. Because I tell you these two figures are similar, what do you know about all their angles? They're the same, right? They're congruent. So, while I only gave you 3 of the angles inside this figure, do you know the angle measure for angle B? What would it be? 80, because angle B corresponds to angle E, and because it corresponds and the figures are similar, we know they're congruent to each other. So I know that the measure of angle E would equal 80 degrees. How about the other missing angles up here? The measure of angle E, that's 80. How about some other missing angles? Skylar. Go, just do one of them. I'll call other people then.
H equals 110.
The measure of angle H is 110. Okay. Chris, how about the measure of angle G? 70 degrees, good. And last, the measure of angle F. Jeremy, the measure of angle F.
F?
Yep. F's right here. It corresponds to which angle in this one? C. And we know that corresponding angles are equal, so therefore F has to be 100. Yep. Alright, angle simple enough? Alright. So we got all our angles right here. Now the sides are not equal, but they are in proportion to one another. Okay? Side AB corresponds to which side in the other figure? HE. So AB corresponds to HE. So would it be okay if I wrote 4 over 12? Okay? So 4 over 12, the ratio of this side to this side would be equal to what other ratio? Anybody?
All of the other sides.
Pick one. 4 over 12, so AB over HE, whatever that ratio is, it has to be equal to, pick another ratio that would be equal to. AD over HG, so 6 over Z. That work? Yep. Could you solve that for Z? Sure. 4 times Z equals 12 times 6. I believe Z would equal 18. Let's set up a proportion to solve for X. I'd always come back to this 4 to 12. 4 to 12 has to equal what to what? 4 to 12 has to equal 8 to X, right? That one probably doesn't take even cross products. If 4 is to 12, then that has to equal 8 is to 24, right? So X is 24. And the last one, 4 is to 12 as 3 is to Y. 4 is to 12 as 3 is to Y. The Y would equal 9. Okay. And my last question, what's our scale factor? What do all of those ratios, 4 to 12, 8 to 24, 3 to 9, 6 to 18, what do all of those ratios equal? 1 to 3, right? Right? So my scale factor is 1 to 3. Okay? So, that should be enough to help you. Your assignment is page 376, number 3, 7 through 17, 23 through 26, and number 31.